Yeah. Oh, here we go. I am going to make that noise. Here we go. An absolute betrayal right away of my program that I used. There we go. All right. It wasn't too bad. Okay, so we started the class with bell work and we factored if you cared. And I went through my whole speech about factoring and how to factor well and blah, 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 blah. There you go. Oh, what was that last one? X minus 1, right? Okay, so we did that on the board and went through my whole thing. Then we talked about synonyms. When you hear these terms, these are all synonymous with each other. Solution, root, 0, I almost feel the same way about all three of them. The number that when I plug it in for x, it turns the whole thing into 0. And then that turns in I don't know, I'm saying it wrong, but you get what I'm saying. And then that turns into an x-intercept for the graph. And then, of course, that comes from a factor x minus k. So this is what I was telling the students. Graph by 0 analysis. Okay, 7th hour. This actually didn't go off too well in the other classes as we started, but I don't think they understood what I was asking. If I multiplied this out, what would the leading coefficient be, and then what would the degree be, meaning the highest degree, and then the rest would be smaller than that? First of all, what would be the leading coefficient? -2. I heard a bunch of different answers. Check yourself before you wreck yourself. Because actually what would happen is you take this times this and times that ultimately. I know it works differently than that, but that ultimately it would be the leading, the leading power, or not the leading power, the leading coefficient. I can't get the words out. All right, and then what would be the degree? 3. So it's a -2x to the third plus blah blah blah. That's if I multiply this out, which you're going to have to do later in the end of these notes. So I'm not sitting up here like a fool and doing the polynomial dance. Don't we all agree at this point that that's what the graph should look like? You better, or else you're severely behind. And that's also the statements that people don't like in my class. All right? All right. Oh, I'm sorry. Wrong. Okay. Jumping ahead of myself. So, ZPP. That means zero product property. If I make this 0, doesn't that mean to find the zeros? If this times this equals 0, the only way that's true is if each factor possibly equals 0, correct? I know I'm teaching this way too slow, but, I'm also getting accused of teaching too fast. You can't win either way. Okay, so what are the zeros? 3/2, right? Hey, what's the second one? Be careful. It's 4. I heard people say -4 in the other hours. And then, of course, subtract 1. And then those turn into x-intercepts. This is how I did the notes back then. Really thought this was a simplistic concept that everyone would understand. I like putting the x-intercepts in coordinate form just to hammer down the point that the y-coordinate's 0. And then you know what you do? You put these two things together. This is how you graph by 0 analysis. Expectation of graph compared to what the x-intercepts are. And that's why this should be absolutely's, positively's, no calculator whatsoever needed. And then if I made the y-axis too big, hey, I'll spread this out. -1. Maybe a little too spread out. 1, 2, 3, 4. That's fine. And then knowing that the graph is supposed to look like that I'm showing you in yellow, really what happens... Oh, I had a great question. And then please focus on this, and I won't pick on individuals like I did 4th hour. What is the y-intercept? I'll pause that and wait for a second for some people to think about that. Yep, you got it, Chief. You plug in 0 for x, and basically you get -3 times 4... I'm choking myself with this cord, sorry. And then 0 plus 1 times 1. All right? I didn't faint, so some people are like, I'm surprised you didn't go, darn. All right? All right, so -12. -12 is the y-intercept, and it would be nice to mark that. I'm way off scale, but it really doesn't matter. And it doesn't necessarily end up being the lowest point. But that fits the intercepts with the expected behavior, doesn't it? And I couldn't care less if I'm telling you to sketch through zero analysis how high and how low the max and mins go. I did? Where's my son of a nutcracker? Fire him immediately. All right, everyone, just relax. Hey, I told you he's a rotten teacher. See his mistakes that he makes? I told you. All right, let's get rid of that. Ah! These videos are awesome. Why does no one watch my videos? Because your videos stink, Mr. S. All right, so 3 halves is 1.5. My bad, dogs. Rough. Am I right now? I'm sorry. I apologize. Okay, we can move on. Sorry they had to be in the video. Thanks for raising your hand and telling me, though. Okay, what do you know about this? I'm not doing the zeros anymore. The zero product property, zeros, then x-intercepts are going right to the x-intercepts. What's the x-intercept for this? We're running out of time. 2, 0. What do you know about it, though? It's a double root. I'll take it. But once they get more than double, you want to call it multiplicities. So this has multiplicity 2. Okay, I'll pause the video, but the question is, what happens at the graph at this particular point? We got, student in the back says it is a max or a min, depending on how it shapes up at the x-axis. Someone else said bounce. The word that's in math actually is this word. Watch this. Oh, that's my worst circle of the day. I've been drawing really good circles. What word is that, everybody? Tangent. So actually, right? Isn't that tangent? How many people said tangent? Raise your hand. How many people thought it and just didn't say it fast enough? All right, and then a lot of people didn't do anything. All right, that's fine. That's what happens. It's actually tangent. That's the math word instead of bounce. Tangent to x-axis. And I'd like you to write that word down. That's why I wrote circle with the line that crosses it only once. It's a special line. And then -1, 0. But that's really the correct word for that. Right? And we're mathematicians in a high-level math class. We should be using math words. All right, now, here's how this shakes out. 2, 0. Let me make sure I'm slow on this one. -1, and then 3, 0. All right, so far so good. I got to be careful here. Oh, I'm sorry, I forgot to ask you. If I multiplied this out, everybody, what would be the leading coefficient? 1. What would be x to what power, X to what power? 4. So expectation, and it would be x, 1, 1, 1. This would be x squared when I FOIL this out times another. You get it, and you should. It would be something like this. And behavior, polynomial game. So how does that shake out with a double zero that has multiplicity to tangent to the x-axis? Well, here's the last x-intercept, and it's not special. It's a normal one, so it crosses all the way through. By the way, just for giggles, what is the y-intercept again? What's the y-intercept? Oh, I don't know about again. What was the last one? What's the y-intercept for this one? No one got it this time. Boom! It's -12 again. What's 0 minus 2? What's 0 minus 2? -2 squared is what? 4. And then 0 plus 1 is 1. 0 minus 3 is -3. Oh, hopefully people aren't looking at me like a deer in headlights because they don't get that. You plug in 0 for x, you evaluate to find the y, that's the y-intercept. All right, good catch on whoever answered that in the back there. Can't put your name on the internet, I'll get sued. All right, and then this is a bouncer, so it stays below and bounces. Now what I did back in the day was we looked at it on the graphing calculator. We're just going to skip it. You should know how to do this and know and remember. And hopefully I'm reaching in that brain and, oh, yeah, okay, I remember that. All right, this is what will be on your quiz, you know. Hey, that one's the same. Now it's not because I'm going to put a cubed on here. All right. And then it's the same one as the last one, except I put a cubic on that one. And then I will go to the graphing calculator on this and show you what happens. I'm going to press pause. Okay, so now we got the video back on. I promised I would graph this just to look at this to see what the behaviors are. I'm going to zoom standard because I don't know what I had it on for my previous graphing. All right, and then this is your job, and I'm not pulling this onto my note screen because I can't. It screws it up. Hey, there's that double zero. Do you see it? You see it? There's that tangency to the x-axis. And then don't you agree that this one, I wish this pointer would show it better, the one on the right is different than the one on the left? The left does a little something different, doesn't it? As a matter of fact, it looks like a cubic function, doesn't it? Remember the cubic? The x cubed function looks like this. You know, for your parent functions, it has that little flatness in the middle. And I'm going to demand that from you. Whenever a 0 has a multiplicity 3, it looks like a cubic when it comes through that 0. It does pass through and go to the other side. It just does it in a special way. All right, so our zeros are 2, 0, mult 2, multiplicity 2, negative 1, 0, mult 3, and then 3, 0, you don't have to say multiplicity 1. There's just nothing going on with that very special. Okay, and then when we go to graph this, you're going to have to know without a calculator that this is what happens. 2, 0, negative 1, 0. And I know you just saw it on the calculator screen. The point was just to show you what happens. And then 3, 0. Me too. Still, oh, I'm sorry. I forgot to ask this. This is crazy. If I multiply this out, what is the leading coefficient? It's still 1. And then what is the x? X to the what power? 6. So it still does this. At least it has that end behavior up and up. That's why I want to know the leading coefficient as well. It could be down and down if the leading coefficient's negative. All right, and then I guess that's all you really have to look at here to know how this would shake out without a calculator. All right, this has mult 3, so this is what I got to do. I got to show that cubic behavior like graph, and I do have to do that. Hey, I got a question. What's the y-intercept? Yet again. It's negative 12 again, because 0 minus 2 squared is still 4, 1 cubed is still 1, and then 0 minus 3 is still negative 3. It's 4 times negative 3, which is negative 12. Really wild. Am I saying you have to do that? It's good to know. You should know a little bit more than maybe what you'll get tested on, but you should know how to get y-intercepts. Always. I will be checking for that cubic behavior, all right, on a multiplicity 3. By the way, what do you think is going to happen with a multiplicity 4, 6, 8? Who do we appreciate? Not Mr. S. Numbers. He's a jerk. Do you think it'd be the same? Yes. As a Federmact, I had no time. You know, I was, you know, I just do math for fun, and I did that once. And I said, what happens if I make that an 8? What happens? What's the difference here? And this is just for extra, you know, stuff for you. This doesn't change, but then this is what obnoxiously happens. Oh, sorry for that little squiggle there. A little too excited. It goes like this, like right away, and then it gets super flat. Then it goes, woo! That's all that happens. It just gets really obnoxiously close to that 0 right away. It's still, that's not your responsibility. Your responsibility is just to show that it does this. And then the same thing with this, multiplicity 3, 5, 7, 9. All that happens with a multiplicity 9 is it goes here, then it gets really flat before it goes through. Got it? You know, I don't really care. You don't have to show that. You just have to show that it passes through and, you know, does what it does. Okay. All right, good enough. So I think I could go over these really fast. In exercise 39-42, state the degree and list the zeros of the polynomial function. Didn't we just do that? All right, state the multiplicities of each 0. And then don't worry about don't say whether it crosses or not. I guess they like you to write that. Just do the graph and show that it crosses if it does. So you don't really get a lot of time to write those directions. We just did all of that. Got it? Okay, everybody, what's the x-intercept for this one? Not 2. Negative 1/2, comma. 0. I lost them. I don't think I'm being mean. What's the next intercept? 4, 0, and then what's the multiplicity? And then here's what you should break down. Whoa. What is the leading coefficient? It is 2. And it's 2x to the what for the leading... It's a 2. I love the 4s today. I love these graphs today, apparently. I don't know. I don't know what to tell you. All right. So you put it all together. Yoink. Yoink. Here's -1, so here's -1/2. And then here's 1, 2, 3, 4, 0. And the only one that's special is the 4, 0. So it goes down. Hey, I got a question. What's the y-intercept? Oh, no. What's the y-intercept? It is -64. Numerate. -4 to the 3rd power. Nice. Everyone's looking at it. I'm impressed. So it's way down here. So we'd have to change that scale to make that happen. But this is what I demand. Ooh. That little curvature right there to show that cubic behavior. Right? And that's what it looks like. It looks like you're cubic in your family of 7 or 12 basic functions. And then just because I'm moving along, it's up to you to pay attention. If not, kapow. What is the leading coefficient if I multiplied this out? It is 7. This is what I get from people. Some people want to tell me that 7 is a 0. Incorrect. That's a coefficient. That's just a number floating by itself. If I multiplied the squared and the 4th, I'd get... By the way, what would I get? X to the what? I get x to the 6th, then I'd have to distribute a 7. And that's why the leading coefficient would be 7, and then there'd be a lot more, and that'd be a big pain to actually multiply out. But that's what's going on. You okay over there? Looks like math is painful. All right, so again, what we have is this. Straight up again, my favorite picture. Oh my gosh. Do I dare even... Oh, I was wrong all day long, by the way. Do you know what the y-intercept is on this one? Holy crap. Let's see if you can figure that one out. It's a second. 1. All right. It's 0 plus 5. What's 5 to the 4th? 625. Nice. 625. What's 0 minus 3 squared? What's 9 times 625 times 7? That's the y-intercept. Isn't that nuts? The y-intercept is off the charts, baby. All right, 3. Did someone get it? What was the y-intercept? 39,000? Holy jeez. All right, this is mult 2. I got too excited. I forgot to label my zeros. All right, and then my other 0 is -5, comma 0, mult 4. And here's my point about mult 2 and mult 4. Is it really different? Not really. The mult 4 would just come more flat. If you wanted to show that, fine. It's not really your responsibility. 2, 3, 4, 5. And I think in my other hour, I accidentally called the one on the right mult 4. So if it ends up like this, it's supposed to be like this. If you really wanted to show that a mult 4 is different than a mult 2, fine. It's not really your responsibility. Flatter. Then goes up to 39,000 for a y-intercept. Is that what you said? Something around there. Then 1, 2, 3 comes down and then just hits that normally as a double and then goes up. Now, if you went to the graphing calculator, you'd barely see a thing. You know, this thing would probably just... You'd really have to manipulate your window in order to make sure you get a good picture there. Then that leads to my next one that I want to cover. I'm skipping one. I think I just went overboard. We're going to put that right on the graphing calculator. Right, so I'll press pause for the video. Again, I know I'm taking a long time to explain this stuff. Again, I can't win either way, right? Either take too long or I go too fast. All right, did I ever show you the crazy tube guy? Okay, saying. Do you see everything that you need to see? Do you see everything you need to see? No. As a Fermat act, we said that the y-intercept was what? What was the y-intercept, class? -110. It's right here. If you plugged in 0 for x, you get -110 for y. And I'm missing quite a few wrong. I'm going to go to window. I'm missing a couple x-intercepts, so I'm going to expand. Negative 20 to positive 20. And then just for giggles, in the other hour, I went to like negative 200 and positive 200, and I still didn't get all of the humps. So you keep guessing and checking until you see the humps. You have to keep going, and then I found that probably 400 to negative 400 was fine. But I just, maybe not. Look at that's all the way up there. Maybe not. Boy, I needed 500. I would have cut that off. Now it says in here, I think it says, find the zeros of the function algebraically. You're not ready to do that yet. That requires synthetic, anyone? Division, and maybe you've done it. We're going to do it later, so you can't do this yet. So it has to be graphically. Got it? So what do I do in my calculator? I go to y equals, and what do I type? Make my life easy. y2 equals 0, and then I'm only going to find one of them. You go to second calculate, and I don't calculate a 0 anymore. I calculate the intersect. Watch. The first one, all I have to do is press enter 3 times. For any of the other ones, you just have to arrow over on the first thing close to one of them. Got it? Now, this would have been good through synthetic division and algebra, but we'll learn that later. That's what this whole chapter is all about. Okay, so you get what you get. Find the zeros. You could do that. I found one of them. You could find the other two. The last ones. Oh, people are putting their stuff away. It's 54. The last one is, and I guess I'll do this as maybe you walk out the door, is they give you the zeros. Now they want the polynomial. Zeros turn into factor. What's the factor for 3 being a 0? X minus 3, and then what? X plus 4, and then what? X minus 6. I'll multiply that one later. Watch this one. I really want to help you on this one. So we'll call this g of x. I'll multiply this on the end of the video if you want to watch this. But watch this as you walk. X what? X minus root 3. And then x what? Now, here we go. See, he calls me names. You're a silly fool. What? If you do not multiply these two first. Does anyone know why? They're like conjugates almost in a way. The middle term cancels. You're creating your own problems by not multiplying this. This. Here's foiling, by the way. I'm not teaching FOIL. Okay, here's FOIL. What's root 3 times root 3? 3. Freedom. And then what happens to this? These destroy each other. So actually that turned into x squared minus 3. And then all I have to do is multiply that by x minus 4. And then that's another FOIL. X squared times x is x cubed. I don't understand why the kids can't FOIL. I really don't. It makes me cry at night. Minus 3 times x. And minus 3 times minus 4. And then as you walk out the door, this one is not as nice. F of x equals x squared. Oh, come on. Plus 4x and minus 3x is plus 1x. Nobody's listening right now. They're all just getting their books away. They're like, I got to get out of this class, get some freedom. Finally, this guy is just talking. Who is he? Listen to him. Listen to him. This is what I deal with every day teaching. Hey. And then you take this times this. And then, oh, I'm sorry. I was talking about the kids too much. I'm going to group them like this. So like terms are actually nice lined up. You don't have to do this. Just know how to get like terms. And then minus 12 times x, minus 12x. And then they're lining up at the door. I don't really want them to do that. Well, they're not getting up. They're about ready like a track meet to get out of here. 72. And then f of x equals x cubed minus 5x squared minus 18x plus 72. And that's all she wrote.